Okay, let's look at some of the homework problems in section 16.6. And the first one we'll look at is number 2. So we want the part of the plane that this lies in. Oh, okay. For surface area, you would take f of x, so that's minus 2 squared. F of y is minus 5 squared plus 1 dA. Now, if it's inside this circle, if that's r, the area of that, it's a circle radius 3, is pi r squared, which is 9 pi. So when we do this, that's going to be square root of 30, and so the double integral of the dA gives us the area of that disk, which is 9 pi. So that's all we have to do. We don't even have to integrate it. Because, let me go back. Square root of 30 is a constant, so that can come outside. And this will give you the area of the region, which is just 9 pi. Now, they're not all going to be that simple, of course. If we look at number 4, and the triangle is this. So we're going to integrate it over that region. First, let's go this way. So that's going to be from 1 to, okay, the equation of this line is going to be, it's rise over 1, so it's 1/2 x. And then we're going to go from 0 to 2. I keep forgetting we're doing surface areas, so we need the square root of fx squared plus fy squared. Now, this is going to be hard to integrate with respect to y, because that's going to be 16y squared, and we don't have another y in the problem, so we can't use substitution. So we're going to have to change the order of integration and go horizontally. So that means x is 2y, so we're going from 2y to 0, and then we're going to go from 0 to 1. See if that's any easier. So that's going to be 9 plus 16y squared plus 1 dx dy. Well, that's going to be a lot easier because that's just a constant. That's with respect to y. So we have that's just going to be this. And then we're going to integrate that with respect to y. And that's going to be easier because now we have an extra y and we can use substitution. Let's change the limits of integration also. So this is going to be 1/16 26 to the 1/2 minus 10 to the 1/2. Okay, and then for number 18, we're going to use maple. So we're going to graph this. Okay. And we're going to go with plots so we can sketch it. Oh, hold on. That was, let's do this one too. This was the example that I did in the lecture. Let me graph it just to, that's the one I just did in the lecture. Just to see what the picture of it looks like. Oh, let's do, I need a Z in here with implicit. Okay, and then I'm gonna, so you can see that it's kind of rounded and it's kind of a square shaped thing. We found the surface of that area um, in the lectures. Now let's try this one. This one, okay, we're gonna integrate. We have to, okay, let's go back to the notes and I can write out what we're doing. Let's see. Okay. Let's do 18. So I'm going to go from -2 to 1x, -1 to 1y. F of x is 1 plus 2x. F of y is 1. Okay, now we're going to use maple to do that. We're going to do the integration with respect to x first. So we have int square root of 1 plus 2 times x squared plus 2 x equal -2 to 1. Forgot my parentheses. And I'm going to integrate that. With respect to y, let's simplify that, see if that gets any simpler. No, let's combine it. I know the ln's can be combined. Okay, that helps a little bit. Let's try to simplify that. Okay, and there's our approximate, and that's an exact answer. Sorry, for number 18 it says find the exact area of the surface. So if you wanted to approximate it, you would evaluate that. It's about 12.913. Okay, let's graph it. And we get like a parabola. So the area of that surface is about 13 units. Okay,